Well, let's go ahead and get started. So, good afternoon. My name is Larry Morris, and with me is
Reese Oxenham. Good afternoon.
And we're going to walk you through a little bit of the Edge roadmap we have going forward. As an agenda, what I want to do is maybe spend the first period giving you a little bit of an overview of the Edge market, how we see that market, and some of the things we're doing to try to make it a little bit more segmented and focused as we bring our products. Then I'm going to go into the Edge product, what I would call the core, and then we'll transition and have Reese go into the 3.0 roadmap and talk to you about what we're doing a little bit further out. All right? So let's talk a little bit about this market. As we talk, and we talk to a lot of Edge customers, we hear some common themes. And if I were to summarize those down, which I did, these are the top four. So the first thing that we hear as we talk to customers, and I'll give you a couple of examples. We've got two very large, well-known retail customers we're talking to today. They both have estates where they have tens of thousands of locations. So this is the first thing that we're hearing from customers. I've got a distributed, large environment that brings complexity in how I manage it and how I administer it. And I'd like to have a solution that helps me simplify that. The second thing that we hear as we talk to customers is that the data, while it may not be in a public cloud, while it may not be in my data center, is every bit as mission critical as that information, and I need it to be secure, I need it to be locked down so that people cannot tamper with it or get access to it. The third thing, and I'm seeing people nod, so I'm just making sure this resonates with the customers we have in the room. The third point that we hear is that these customers want to focus on their area of expertise. I want to be able to focus on optimizing my business, managing my business, getting the maximum value out of my business. What I don't want to invest resources into, what I don't want to have to put people to focus on, is the infrastructure underneath that facilitates the applications that I need to deploy. And the fourth area that we hear as we talk to customers is a desire to have a single common platform from their public cloud environment into their data center and into the Edge. That resonate with you? All right. So Edge is a very complex area. As we talk to customers, what we started to do is to segment it into three different areas. And I'm going to go into that a little bit more detail and give you some examples why. So the first area we see, and it's not one of these segments, but our customers really come from one of two different areas. First, it may be that they're brand new to taking compute and putting it into their Edge infrastructure. The compute platform, the infrastructure has now reached a point where it makes business viability to start to put these into Edge locations. So that's kind of the first camp. The second camp are customers that are looking, how do I modernize? I've been running in an Edge environment for some time, perhaps it's hosted in a VM, and I'd like to move it to a cloud-native infrastructure. How do I get the optimizations from that? Because I'm already doing cloud-native in my data center, and I'd like to be able to keep that consistent across my environments. So those customers come from these two camps, but now we start to see a lot of disparity from them. Give you some example of use cases. It could range from a 5G telco infrastructure. It could be a point-of-sale terminal in a retail environment. It could be a smart traffic management system as part of a smart city. It could be an in-hospital patient monitoring environment. It could be an industrial controller in an oil and gas environment. There's a lot of variability there. Some customers want to run it on very small, even like a system on a chip type of a computer. Others are putting it on a very large system with multiple 256 core processors running gigabytes of RAM. So a range there as well. So as we've looked at this, what we've started to do is segment it into three areas. We talk near edge, we talk far edge, and we talk tiny edge. And what's interesting is we brought this terminology out about three and a half years ago. We were about the only ones using those terms, and now they're starting to get much more broadly adopted, and other people talk on these three areas. So near edge. Near edge is really the domain of the communication service provider. Okay, what's a communication service provider? Really simplistically, it's a telco, it's a media or entertainment, it's your internet provider. Those are the large customers we think of when we talk about a communication service provider. Then you get further away from the data center, so near edge is the closest to the data center. You start to get into far edge. Far edge, we in that particular segment, we put customers like manufacturing, retail, hospitality, healthcare, public sector, oil and gas, or financial services. And then you go furthest away and you get into tiny edge. So tiny edge is really the domain of the industrial IoT, right? So these are customers that have sensors, cameras, other instrumentation in their environment that's networked together that they use as part of their automated manufacturing or the materials that they use as part of an oil gas recovery process. All right, so you see quite a spectrum there, and we have decided the best way to address this is with purpose-built products for each of these three specific markets. Let me go into this a little bit more detail. So the first product I want to talk about is our SUSE Adaptive Telco Infrastructure Platform. This particular product is designed and optimized for the communication service provider market. SUSE is part of a Linux Foundation project called Silva. Most of you probably not heard of Silva. Silva is a foundation driven, and it started really on the European Union side with companies like Orange, depending on whether you're French or not, Vodafone, Deutsche Telekom, Telecom Italia, and Ericsson and Nokia. So this gives you a very concerted group of very interested customers driving what they want to see in the next generation of their telco infrastructure. SUSE was one of the first members as part of this foundation, has been working all along with them to really drive and put together this telco infrastructure. All right? Then as you move a little bit more into the far edge, and this is the domain of, again, manufacturing, healthcare, public sector, we have a second solution called our Cloud Native Edge solution. This product is really designed for the particular use cases in that segment of the market. And let me give you a couple examples of these in a little bit more detail. So this is actually on the left, the infrastructure that exists inside of a telco tower today. As you drive past that, I don't know if you're aware, there's a significant amount of infrastructure and telco capability in there to process and take the information from your phone as rapidly as possible, process it, get it on the network, and get it out to the other side so you can communicate with who you're communicating with. So our adaptive telco infrastructure product today is deployed in these types of environments, and we're helping those customers start to modernize and improve the 5G infrastructure that they have. This is an example of the far edge. So what you can see on the, and I guess it's on your left, is an example of a 3-node cluster that is deployed inside a retail establishment. So they use this for inventory management, for time tracking for their employees, online order processing, all the things that you do as part of a small retail establishment. And this kind of makes it real to give you an example of two of the real-life examples of customers that we have. Now, while we focus on these three common markets, what we've found is that we've got a common core platform itself that really, it goes across these three segments of the market. And then what we do is add vertical market specific capabilities onto these three products. And let me go into a little bit more detail into this core product itself. So at the foundation of this core product is a purpose-built Linux operating system. When we first came into the edge market 3 or 4 years ago, we recognized that we already had in our portfolio all of the products that we needed to create an edge solution stack. We had the Linux operating system, we had the Kubernetes infrastructure, we had the Rancher management framework or our SUSE manager framework, we had a block storage solution with Longhorn, and we had security solution with SUSE NuVector. This really became the core of the solution that we put together. Now, we just didn't take these existing products. We had the expertise in the organization to help us build purpose-built solutions for these. The best example, and the first of these, is the SUSE Linux Enterprise Micro solution that we had built specifically for these cloud-native edge containerized deployments. This particular release, it inherits all the goodness from our SUSE Linux Enterprise product, so all of the compliance, all the certifications, all of the build security that you have when you build an enterprise Linux, and then it becomes a very modern and developer-friendly environment with a small footprint. It's designed for smaller, environments. This really is our Linux environment. Now, we've gone on top of this and provided a couple of vehicles to manage the life cycle of this device. One of those is called Elemental. So Elemental is a plugin that goes into the Rancher environment that enables customers that are interested in a cloud-native methodology for managing the operating system to do it in a cloud-native way. So Elemental will go out to a registry where you have the latest version of the SLE Micro operating system. It will pull it down and go ahead and update in a GitOps fashion your entire estate. So very good when you're talking about these thousands or even tens of thousands of locations. The second option we have is to use our SUSE Manager solution. Some of our customers prefer more of an RPM or a traditional approach to patching the operating system and selectively choosing what options they want to bring in. But both of these are enabled as part of this purpose-built SUSE Linux Enterprise Micro operating system that's the foundation of our release. On top of this sit either one of our two industry-leading Kubernetes releases. Let me talk about both of those very quickly. So RKE2. RKE2 is our CNCF, or Cloud Native Compute Foundation, compliant and certified Kubernetes release. What that means is it has all the APIs, all the compatibility with existing upstream. It is a full-featured, full powerful Kubernetes release. This really is the primary one that comes in and is deployed as part of our SUSE ATIP solution into the telco market. The second option we have is a product called K3S. So K3S is the most widely adopted small footprint Kubernetes distribution in the world. What we've done is selectively removed capabilities from that we don't believe are necessary for these smaller deployments, and in doing so reduce the footprint. It's about 100 megabyte binary size, which is very small for a Kubernetes environment. Now with this release, it also has a very established community behind it. When I looked yesterday or the day before, there's almost 1,800 engineers that have contributed to K3S. It is a SUSE product that we committed to the upstream Linux Foundation, and because of that it's used by other companies, including Microsoft and Google. Okay? So these are the two Kubernetes versions we have. The heart of this, with Linux being the foundation, kind of the heart of our solution, is our Rancher Manager orchestration framework. So this is a zero-touch environment that enables you to configure, establish, and manage your Kubernetes estate. Now there's a couple of plugins that we've done with this. As I mentioned earlier, the first of these is Elemental. With the Elemental plugin, I have a CNCF, or a cloud native methodology for managing my Linux lifecycle. There's a second plugin I didn't mention, which is called Fleet. So Fleet also enables you to do a GitOps methodology for managing your applications. So what we have now within Rancher is a capability to manage the Kubernetes layer, the Linux file system and operating system, and the application, all from a single pane of glass. Let me move a little bit more into the stack. So on the right side, you can see the Rancher Manager stack I just talked about. Again, a single pane of glass to manage the full life cycle. This can be hosted in a cloud environment, or it can actually run on hardware that's closer to the where the edge location is in the edge environment. On the right side of this, you see our edge solution stack with the SLE Micro Kubernetes layer, but there's also a couple of other products I didn't mention earlier that I want to touch on very quickly. The first of those is our SUSE NuVector product. So this provides a zero trust cloud native security environment. It's got its own cloud firewall that it brings in, where it basically watches very closely for known vulnerabilities or even suspicious communication paths coming into the device. It'll also do deep packet inspection on any of the communication packets going between the pods or the respective nodes in the cluster to ensure that there's no suspicious activity taking place or communicating between those. So it really gives you enterprise-grade security locking down this environment. Now, we combine this with the What we do with that, back to the SUSE Linux Enterprise micro operating system, we've made it so that the runtime kernel, when you bring up the system, is designed to be immutable. When it's immutable, that means it cannot be written to. So if I'm in a retail establishment and I've got the 18-year-old who's looking back there thinking, how do I get a thumb drive into that system and gain control of it? You can't, because the operating system is locked down and it is immutable. Between those two, we have true enterprise-grade security. And then we also have a block storage solution called SUSE Longhorn. This provides you with persistent storage in your Kubernetes environment. So you can start to see how this framework and this solution really comes together. Watching our time. So let me go ahead and just kind of summarize it here with this slide, and I'll go ahead and transition to Reese to give us a little bit more on the roadmap. So 4 key points I brought up at the beginning of this presentation. So the first of those, which is how do I manage the complexity at scale of this environment? That's one of the first things that we really focused on, is basically providing a purpose-built solution stack which is designed from the ground up to manage your complete life cycle of your edge environment at scale. And we do this with Rancher Manager, we do this with the Elemental plugin, we do this with all the things that we're thinking through to enable customers, whether they have 100 edge deployments or 35,000 edge deployments, to make that simpler and more automated and more abstracted away from them. The second thing is security. Security, security, security. Between NuVector and the immutable file system, we've given customers enterprise-grade security for their environment to really lock it down and provide them with the confidence, whether it's a HIPAA database that needs to be controlled, or whether it's customer information or credit card information sitting in a retail establishment. How do I ensure that that information is guarded and safeguarded? The third piece of this equation, as I'm moving right to left, is really the Rancher Manager and how it automates everything that you do. From the plugin for Elemental, which gives you the GitOps capability to manage the operating system, to the Fleet plugin, which gives you the GitOps capability to manage the application, a single pane of glass to orchestrate and do everything with your environment. And then lastly, combining it with the world-class support that SUSE offers, and probably just as important is the world-class consulting organization that we have. You know, if you're one of those customers that is looking at a new deployment and have not used compute in the edge environment, sitting down with experts that have sat down with multiple customers before and helped design a solution on how you bring this to market is extremely valuable. And SUSE has that consulting capability. All right? So with that, let me go ahead and transition to Reese, and let's start talking a little bit more about some of the product features we have coming in.
Thank you so much, Larry. I think I also missed my cue earlier to introduce myself other than just saying my name, so I apologize for that. I'm Reese Oxenham. I run the engineering team. So Larry looks after product management. I run the engineering team. So together, we're delivering our product. Yeah, absolutely. So I'm going to talk a little bit about SUSE Edge 3.0, what we just released. I can see a few of my colleagues in the engineering team are here, so thanks for all of your support with this release. And then I'm going to talk about where we're going in the future. Okay, give you a little bit of a sneak peek into what comes after 3.0. Before I talk about exactly when into 3.0, Larry sort of talked about the various different use cases that we have to start to deliver solutions for. But I want to try and set the scene as to the types of experiences and what we have to try and deliver towards when our customers come to us. And we've really identified that customers absolutely want a zero-touch provisioning model, but there's no one-size-fits-all deployment model that our customers are expecting us to do. So we've identified 3 key differentiated provisioning models. The first one on the left-hand side is directed network provisioning. The idea here is that there are known systems, so perhaps, for example, there is a cell tower, telecommunications tower, someone has racked the hardware there, and the expectation is that an internal team will contact someone else and say, hey, I've cabled all of these machines, a centralized infrastructure needs to automatically go ahead and provision all of those machines. So completely hands-off from Metal all the way up through to operating system, Kubernetes, running applications. That's the first paradigm that we have to address. The second one is this kind of large-scale phone home network provisioning. This is what most people think about when they think edge. It's tens or hundreds of thousands of devices booting up in the wild. They are generally unknown systems, so something completely different from the first one. There will simply be machines that are perhaps imaged at the factory, or they are re-provisioned at the edge site, and they phone home to a centralized infrastructure, and the centralized infrastructure takes over responsibility. An administrator, or through some kind of GitOps paradigm, automatically rolls out the infrastructure. But these machines are unknown at initial boot. The third one is what we call image-based provisioning. And this is somewhat a completely different paradigm in that the first two are assumed to be connected machines, in that they have an internet connection or they have some kind of connection to a centralized infrastructure. In the third, image-based provisioning, we assume or we default to the idea that these clusters are completely air-gapped. They don't have any access to a centralized infrastructure and that they have to bootstrap in place. All of the deployment resources, so the operating system, Kubernetes, user workloads, any customizations that are required are pre-baked into the image that gets deployed, and that it comes up without any kind of user intervention, without any centralized networking implementation whatsoever. Now, just because you may have chosen this doesn't mean that you can't exploit the benefits of having connections to a centralized infrastructure. This may be good if it's not necessarily an air-gapped environment, but maybe an unreliable network where that may come and go. But when the machines do come online or network is established, maybe it's a 5G or a satellite connection, you can then start to receive updates from that remote cluster. So 3 distinct paradigms that we have to address, and we have a solution for all 3. So what have we actually delivered with SUSE Edge 3.0? I know there's a lot of words on this slide. There's a lot of work, believe me, that went into this solution. But I want to break this down into kind of 3 different sections that overlap with what Larry was talking about previously. So the management at scale, how do we address some of these concepts, and how do we address those 3 paradigms? The first major investment that I want to talk about is Edge Image Builder. And if you are unfamiliar, you haven't seen the demo, go downstairs and see it on the technology showcase. You can see it in action. But the idea behind this is that we need to provide our customers with a mechanism to deploy ready-to-boot images. So they take the full customization of the operating system, networking configuration, additional patches, and they do so that you simply have an ISO or a raw disk image, you plug it into your machine, or you write it out to the hard drive at the factory. These machines boot up and they either bootstrap in place with the image-based, or they phone home via to a centralized management platform, and away they go. So supports fully air-gapped and connected support. We can do full branchless Kubernetes bootstrap at the edge. So this is obviously very good when there is no centralized connection. You just say, these are my 3 machines. I want them to establish a highly available configuration at the edge. We're completely unattended. Can absolutely do that. It integrates with Elemental. So there's essentially 2 parts to Elemental. There's the initial registration that gives us the ability to attach to that centralized infrastructure. And then there's the Elemental paradigm for managing the operating system. So for some customers, especially if you're bootstrapping at the edge with no centralized communication, Elemental connection for managing the operating system is not possible. But for those customers that do have that, we provide that option to do that. We also provide the ability to integrate with SUSE Manager. So this is for those customers that aren't using Elemental to do the operating system management. SUSE Manager provides a great mechanism, a very scalable platform for doing patch management of your operating system. We also worked very hard on the the directed networking provisioning use case, so that we can do the bare metal all the way up, fully automated. You don't even need to plug USB sticks into servers. It does that completely unattended. And we use Rancher, Cluster API, and Metal Cube to take care of those capabilities. We do the operating system, we do RKE2 deployment, and we have worked very hard to create thoroughly validated telecommunications profiles. So if a customer wants to stand up a fully optimized, ready-to-go platform for telecommunications applications, we have all of these available today. In terms of security, we worked on a much lighter version of NuVector. For us, there's no kind of one-size-fits-all edge. They can be data center-grade hardware. They could be tiny little Raspberry Pis. We want to really shrink that footprint as much as we can to make it adaptable for a wide variety of use cases. So for systems that are really resource-constrained, the edge-optimized version works very well as well. Edge 3.0 standardizes on SleeMicro 5.5. That was the latest version of SleeMicro that was available at the time. You will have likely seen announcements of SleeMicro 6.0. We will be moving to that in the next few months, but right now it's 5.5. This gives us some incredible security benefits. First of all, the ability to put the system into FIPS mode. We have SE Linux and enforcing by default, and we have a wide variety of default optimizations to really harden the system. As Larry mentioned, Rancher Prime is how we stitch all of these nodes and clusters together. It gives us that onboarding experience. It gives us the ability to do lifecycle management at scale. Some additional things that we delivered with 3.0 as well, edge virtualization. So for those of you that are familiar with some of the virtualization capabilities of SUSE, you'll be familiar with the Harvester solution. This is not Harvester. It's the lightweight KubeVirt implementation of that is shared between Harvester. So this gives you the ability to run virtual machines at the edge, but not with a flashy UI and all the migration tooling. It is expected that customers doing this are doing so because they have tens of thousands of these machines, and their management experience is not to log into the UI or the GUI of these machines. They are managing them just like they would any other containerized application. So they're doing it via an API. They're doing it via a GitOps type paradigm. Okay, but we do support the ability to run virtual machines at the edge, but it is done in a more of a container native way. We also support Metal LB, so in bare metal machines, you don't necessarily have an API you can call out to say, hey, give me a load balancer, but Metal LB provides us to do that. We launched some public results of our stack validation platform. This is something Basil will touch on in his keynote tomorrow. This is something we're incredibly proud of inside of our team. The main people involved in this are actually in this room. This is where we do very comprehensive CI validation, doing product integration, behavior analysis, chaos testing to make sure that we can release the world's most stable, most thoroughly tested and comprehensively validated edge solution possible. And we have all of those test results in the public. 4 technology preview items went into 3.0. The first one is ACRI for industrial IoT management. Customers want to discover industrial IoT devices. This gives them a great way of defining what we call device handlers. They can look at various different protocols like CAN bus, Modbus, OPC UA, things like that. We have 2-node HA mode as technology preview. Certain customers, they either have, from a cost perspective or a space perspective, they want to have a highly available 2-node configuration. We worked with Synadia, the commercial entity behind the NATS project, to be able to offer a comprehensive 2-node multi-control plane node. So it's not just one controller, one worker, it's 2 controllers. So that's you can actually see a demo of that downstairs. Mesh expansion with Linkerd. So if you are running in an environment such as manufacturing where there's a lot of legacy infrastructure, a common ask from our customers is, well, how can I bring some of that quote-unquote legacy infrastructure into my Kubernetes implementation, make sure it's secure and the authentication is controlled between the devices? Mesh expansion is a great way of doing that. You can connect those virtual machines or those Windows-type machines into the service mesh and discover those and bring everything in collected. Another one as well is one of my colleagues in the team also gave a demonstration of kind of what we call Rancher Hub. The idea behind this is that it is natural when you're managing a fleet of tens of thousands of clusters, you are likely going to have multiple Rancher instances supporting that scalability. It's not only a kind of a requirement when you're talking about tens of thousands of clusters, but also it's good practice from a bandwidth availability type situation. But our customers, they want a single pane of glass. And so we've been working towards the implementation of this kind of Rancher Hub implementation. So that's 3.0. I mentioned Edge Image Builder. This has been an incredible, I'm actually amazed at how quickly this came together from initial kind of discovery, inception, and delivery. I kind of talked through this and how it adapts to the various different deployment scenarios, but on the left you can see how this works. You bring in a SleeMicro 5.5 image, you apply what we call an image definition along with some additional configuration files, for example, doing your elemental integration and various other things. You run it through our containerized Edge Image Builder solution, and it generates the customized ready-to-boot image. Plug it into your machines, they provision, they do whatever you requested it to do. We also worked really hard on validated designs. We hope to ship these in the next few months. The idea behind validated designs is that we are providing a lot more opinionated and prescribed configurations that may be use case or market segment specific, to give a lot more confidence and trust in our solutions to our customers, so that they are not building from scratch. They're not taking these components and assuming how it should be put together. These are tried and tested designs, and as I said, I hope to make these available in the coming months. So why SUSE Edge 3.0? I think Larry covered this off pretty well, but going into it a little bit more, some of the things that we've really worked on are that initial onboarding experience. For many of our customers, if they're working in retail stores, they're not going to necessarily have Kubernetes experience, right? It needs to be as simple as a box gets shipped to the retail store, someone plugs the power network in, walks away, everything takes care of it. This is something we've really worked very hard on. Cluster management. Many of our customers want to have fully automated operations. A machine turns on, the centralized management infrastructure knows all about that cluster, it knows the location, it knows exactly what needs to be deployed, either done via UI or done via CLI or indeed GitOps type practice. Operating system management. This needs to be super simple. We want to remove the burden of managing the operating system. The operating system is arguably the heart and soul of the platform, but it's sometimes many organizations, they think, well, that is kind of an overhead for us. We want to focus on our business differentiation. It's our responsibility to make that super simple and very easy to maintain. Deployment. When we talk about deployment, what we're really talking about is deployment of applications. How can it's fairly easy for me to run Helm on one system, but how do I do that for 10,000 systems? How do I manage the fleet of machines and ensure consistency and ensure that things aren't drifting away from the desired configuration? Security, we talked about. We do not compromise with anything that we do with security. We do pretty much all of our testing with the most hardened configurations, because if it passes in the most stringent configurations, then we know that we're going to be good for pretty much everything else. Then observability. We have a lot of observability implementations in the solution today. You will, of course, be aware of the acquisition that we made earlier today. You can see this be expanded to address some of the new capabilities that we'll have with our friends from StackState. SUSE Edge 3.0, in the interest of time, I'm going to whiz through this. Is kind of repeating a lot of what Larry said, but faster time to market, bringing the power of open source to the edge, deployment at scale. This is, of course, something that is kind of our driving mission here at SUSE, and bringing the experience and expertise we have around delivering security all the way out to the edge. So, SUSE Edge roadmap, where are we actually going with this? Well, again, I'm afraid to say it's another eye chart full of text, but I'll try and provide a lot of context as to where we're going and what we're doing. So, there is a statement in the top right-hand corner. This is speculative at this stage. Things may change, things may fall off, we may add things, so no commitments are being made here, but this gives you a general idea of what we're trying to drive towards, okay? The big change I want to make everyone aware of is that we will now be releasing a new version of SUSE Edge roughly every 4 months. So we're doing 3 releases per year. So you may think there's not very many deliverables going in here, but 4 months, believe me, is not a long time from a development perspective. So on the left-hand side, you've got SUSE Edge 3.1, roughly September timeframe, and then 3.2, somewhat Q1 of calendar year 25, just after Christmas. It's broken down into 5 categories: bare metal provisioning, security, cluster provisioning and lifecycle management, workload support, and then observability. So I'll walk through 3.1 first. So one of the biggest changes that we're making, or improvements or enhancements, is the support for more ARM-based systems. Edge Image Builder, for example, today prioritizes x86-based images. We do a lot more work with x86-based hardware, but of course, many of our customers are running ARM-based systems. There may be other architectures in the future. So enhancing our ability to not only provision and manage ARM-based systems, but also do kind of enhanced workloads on top of that platform as well. In 3.1, we also moved to SLE Micro 6.0. Okay, so this will be the first platform that moves over to that new architecture or that new platform, gives us a lot more hardware enablement, allows us to actually get a lot more built-in security aspects. So this is the first version that brings us things like full disk encryption and things like that. We're also going to be working towards CIS hardening, so there's a CIS benchmark that can be executed on top of a platform. We want to make sure that, of course, the SUSE Edge platform passes that benchmark, and there's a way of validating that your edge clusters are adhering to that benchmark. By far the biggest change that we're introducing with SUSE Edge 3.1 is the kind of the concept of the lifecycle operator. Now, we have produced, or the Edge team is essentially taking various different SUSE components, bolting them together into an opinionated and prescribed stack. Now, putting those components together is one thing, but life-cycling them is a little bit more of a complicated task. You may find that there is a version of the operating system, a version of Kubernetes, a version of layered components. What we are doing inside of this organization is trying to build a solution that is deployed, versioned, and life-cycled as one. So when you're deploying SUSE Edge, you are deploying a very specific version of that platform, one that has been thoroughly and comprehensively tested. When you are issuing a command to your remote edge clusters to move from, say, 3.1.2 to 3.1.3, the platform identifies exactly how it moves from that version to the next. It manages inter-cluster dependencies, the order in which things are taken down. And so what we're doing here is creating a release manifest design, so the platform knows exactly what goes into that specific version, the lifecycle management operator that takes care of those responsibilities, and the ability to use Edge Image Builder to say, okay, I want to deploy that exact version, and it knows all of the various different dependencies that go into it. The other thing we're introducing is Kiwi Image Builder. This is one of the questions that was raised yesterday in the Image Builder track. How do I always generate bleeding edge images or images that have very specific packages? We're going to be introducing a mechanism where through Edge Image Builder you can generate those using Kiwi. From a telecommunications perspective, we're working very hard to introduce things like IPv6 and dual stack support. From a networking perspective, we also know that we have to address some gaps from an Open RAN kind of requirements, introducing precision time protocol and syncy capabilities into the full stack. We're going to continue to expand our work with Synadia and the NATS capabilities and Buoyant and Linkerd. Today, they're technology preview in 3.0. We hope to make these kind of early access, moving towards a generally available model with those customers. We'll always, as always, be enhancing our stack validation platform, doing more tests, introducing more faults into the platform deliberately to catch out behavioral issues, and continuing to ship those platforms to the public. And we have a brand new UI, which I think we're going to run out of time before we can share it, but I'd love to show you some of the stuff that we're doing. 3.2, continuing to work on UI enhancements, especially as it comes into managing bare metal hardware. How do you describe that bare metal hardware? Today it's kind of via the CLI, but how can we expand on that? How can we give more kind of visualizations to end users? SLE Micro 6.1 support. I'm not the engineering team behind the SLE, but if 6.1 is available, we absolutely plan to move to that version. That also brings in things like measured boot support, full disk encryption. We want to continue to enhance the onboarding story for devices going through the phone home paradigm. For that, we want to make it a lot more secure. So we're introducing FIDO-based capabilities to do that secure transfer of ownership for devices booting up in the wild. For those customers that are familiar with the elemental paradigm of using a container image as the boot source, this is currently only available if you're using the kind of the elemental teal variant of the operating system, but we are working on a convergence path so that they are essentially the same in SLE Micro 6.1. So you can move between a traditional paradigm of updating via RPM packages or saying, well, I've got this container image that defines my next desired boot state. So this comes in 6.1. Continuing to address Rancher Manager scalability, so that, yes, we are going to be providing a common single pane of glass for multiple ranchers, but if we can increase rancher scalability at the same time in terms of number of nodes or number of clusters it can manage, but also the amount of bandwidth that's transferred between the downstream cluster and Rancher Manager itself, this is exactly what we're looking to address. Some additional things like dynamic kernel module loading. So if your workload requires a kernel module, you should be able to load that directly from Kubernetes, for example. For our telecommunications customers that are pressure to look at more energy efficient or more sustainable solutions, introducing real-time kernel support on ARM-based platforms is a great way of doing that. Kepler is a tool that can help with managing or monitoring, visualizing the power consumption, so that kind of goes hand in hand with that. Podman support for customers that maybe Kubernetes is too heavyweight for their hardware. You're thinking, sub 1 gigabyte RAM-based systems, maybe Podman is the only option there as well. GA for Acri for doing the device discovery for industrial IoT. More KuVirt support, so maybe additional capabilities for managing virtual machines at the edge. Support for the technology preview item I mentioned around stitching multiple Rancher UIs together. And then, I don't think I've told the team this, but distributed stack validation is something we really want to look at in the future. The idea behind this is that our customers and partners should be able to run the validation tests in-house. It's a great way of us being able to scale, especially from a partner perspective. We can't have all of the hardware, all of the third-party integrations in-house. It'd be a great way if we could roll out that testing framework for our customers and partners as well. I think I'm right up on time. So I did have plenty more slides, but as per usual, I'm far too verbose with every single thing that I do. This sort of gives you an idea of kind of the direction that we're going in. Industrial IoT is absolutely a part of our direction, how we manage that. We have a great partnership with a company called Umoni, who I'm glad to say are in this room today. So thanks so much for your time and support.
You have 10 more minutes. It goes to 5:20.
Oh, yeah. Okay, but I'll leave some time for Q&A. Okay. Yeah. So the idea here is that getting access to data is one thing, right? There's if you look at going back to Larry's taxonomy with regards to near edge, far edge, and tiny edge, what we tend to find in these far edge environments is the tiny edge being very adjacent in a single location. So if you take the fast food restaurant example that Larry talked about earlier, you have these kind of industrial type PCs, but they're also maybe attached to a wide variety of sensors. These sensors might be humidity sensors, temperature sensors, they may be some kind of stock or tracking type systems. These connect to these devices. They connect over common protocols. They can be consumed. The data, getting access to the data is one thing, but what comes after getting access to that data? What we want to move into is a world where that data can be visualized, it can be exported, it can have an API, SDKs, maybe we can do some advanced analytics with AI and ML to actually do that. And so, yeah, I want to mention Umoni is a great partner of ours that are doing just this. And so it's absolutely an area that we continue to expand on. So with that, yep, we very much welcome your questions on where we're going and what SUSE Edge is.
We've got about 7-8 minutes. So.
No questions is fine. Yes?
Yeah, and please go to the mic, yes, because it's recorded.
Okay. I have a question around Elemental and SLEAS Micro. You say, go use Image Builder, if I understand you correctly. When I talk to the Elemental guys, they tell me, hey, go use the Elemental toolkit.
Mm-hmm. Yeah, so if I go back to this slide.
It's converging.
This is the world that we live in that the Elemental type approach tries to predominantly solve for this use case. These machines that are booting up in the wild, they phone home to Rancher, and everything is coordinated from there. Okay? Now that takes care of the registration process, but Elemental today, right now, and how it's been for the last 12 months, you tie the Elemental registration with the Elemental operating system management. So we recognized two things. First of all, there are requirements for fully air-gapped, directed network provisioning where it expects the full bare metal from everything, and even in this world, there are much further customizations and optimizations that our customers asked for that Elemental didn't give us. So we did two things. We broke out the Elemental registration, so you can just do the registration of a standard SLEAS Micro image, and we use Edge Image Builder to build that. Okay? And what we are working to do is converge the two models so that you only have one SLEAS Micro. There'll be one way of deploying and creating that image. And if you want to use the registration capabilities, you absolutely can. If you want to use traditional package updates to update your machines, you absolutely can. If you want to do a container image, you absolutely can. So long story short, we are aware that we have these two models today, but we are converging them in 6.1. Sleep Micro 6.1, yeah, sorry.
Yes, okay. I understand all the words one by one, I would say.
Okay.
No, but,
I know there are a lot of them. Yeah.
no, but I'm just a little bit scared because we have been down the elemental teal road.
Yes.
And now we're being told, okay, that was a little bit of a dead end. We should move to the Sleep Micro instead.
The road that you've gone down is certainly not dead in any way, shape, or form.
Okay, that was the story from the elemental folks. Sorry to say.
Okay, the container image management approach is an option that we have customers using today through Elemental Teal, and it's where we want to get to in standard Sleep Micro 6.1. Okay, so there is a path where these two things converge, but we're aware they exist in slightly different worlds today because they were slightly different paradigms that they were trying to address.
We are in a transitional period of time right now. What I'm just asking for and what I'm looking for is kind of the thinking and the roadmap. Okay, if you are here today, then your natural step forward would be like this and like this. And if you're building a new system tomorrow, then you should do it like this in order to integrate it into your pool of systems like this. That kind of clarity. That's
I understand.
what I'm looking for.
Yep, I understand. Yeah, Elemental longer term will essentially become more of a registry of systems. Okay, and we need to break the two functions of registration and onboarding from how the operating system is built and maintained.
Good. That's clear speaking.
Yeah. Okay.
Other questions? Straightforward?
It is 5:15. I know that there's... All right.
All right. If you want to come up and visit with us after,
I do.
please.
I don't have any question, but I would like to share that tomorrow at 12:30 we are going to present the stack validation thing in this same room. So if you're interested on knowing more about stack validation, we will.
Absolutely.
Okay. Yeah. So this room, 12:30 tomorrow. Edu and Fatih are going to be talking about our stack validation solution, so how we do internal CI, how we do the validation, and I really hope that there will be a brief demo of the new UI that they've been working on.
Right.
All right.
Thank you.
And thanks so much.